And we are on lesson 1-6, I think. Yep. So this would be on the even side, because the odd side we're going to do some examples. Now the reality is scientific notation is taught at an earlier time, and you're taught how to take a number and write it in scientific notation, and take something written in scientific notation and write it as a standard number. But that is the minimum of what we're going to cover. So today is the day we just talked about that, because the real point at this level is how do we do math with numbers in scientific notation is far simpler than if the numbers had all those zeros. So today's date is the 19th. So let's define what is scientific notation. I'm going to highlight this in yellow, because that tells you that's a vocab word that you should be knowing. It's a way to write very large and very small numbers eliminating the zeros from view. That's the whole point, is we don't want to look at a whole bunch of zeros at the end of a number, and we don't want to look at a bunch of zeros between a decimal point and a number. So scientific notation lets us get those zeros out, okay? Matt, do you have something to add to the conversation? Okay. Scientific notation comes up with three pieces. Piece one is there's a decimal. Now there's a stipulation about what that decimal looks like. That decimal is between 1 and 10. Now what that means is something is between, that means it's over the 1 but it's less than the 10. So if our decimal part of our scientific notation is more than 10 or less than 1, then it's not written in scientific notation. So that's stipulation number 1. Next, we're going to be multiplying, always multiplication, and then we're going to have a power of 10. So this is going to help us with those zeros we don't want to look at. And then it's going to have an exponent. The exponent is an integer. So in scientific notation, we can have positive whole numbers, we can have negative whole numbers as our integer, as our exponent. We can't have fractions and we can't have decimals as the exponent. That's the only thing it leaves out. So it is the product, so in words, the product of a factor between 1 and 10 and a power of 10. Now that power, again, that's the one that can either be positive or it can be negative. All right, so let's do a couple of examples. Let's do this. 5,320. I'm just coming up with this. This is part of your notes still. I haven't told you we're not doing solving examples. I'm going to tell you that this answer is 5.32 times 10 to the third power. So let's look at that. What kind of number did we have to begin with? And what kind of exponent did we have? So our two choices for kind of number would be very large or very small. And our definitions of very large and very small is anything that's greater than, is 10 or greater is considered large. Anything less than 1 is considered small. Okay, so based on that definition, what kind of number would 5,320 be? Large or small?
Small. Large.
Okay, if it's greater than 10, it's large. So this is a large number. What kind of exponent did we get?
Cube.
Number's not important, it's the sign that we're looking at.
Oh. Positive.
So this is the connection we're looking for. So, in words, when a number is large, large, and we could say greater than 10, or greater than actually 9.99, ... The exponent,
Wait, this first, is that greater than 99?
9 point.
Oh, okay.
The exponent on the base of 10 is positive. Okay. Let's try another one. Let's see, 0.00041. In scientific notation, that would be written as 4.1 times 10 to the negative fourth power. So what kind of number would we say that 0.0041 is? Large or small?
Small.
He would be considered a small number because he's less than 1. And what kind of exponent did we get?
Negative.
We would get a negative exponent. So here, when a number is small, less than 1, the exponent on the base of 10 is negative. Okay, so when we start with big numbers, we end with a positive exponent. When we start with small numbers, we end with a negative exponent. Okay, so when I had my large number, how did the 5,320 become 5.32? What did I do? What was physically happening from the original number to get to the second one, which is written in scientific notation? Bella.
Take away the 0.
Okay, so the 0 is no longer there. But is that all I did?
No, you put a decimal point.
So a decimal point appears, a 0 disappears. In addition, what else appeared? Matt?
10 cubed.
Well, yeah, and a times. Yeah, so I have multiplication, a 10 with a 3 as its exponent, a decimal appears, and a 0 disappears. Okay, so let's see if we can come up with a description of what I do to change from standard form to scientific notation. Still your note side. No, let's put this here. Still the note side. We haven't gone to the example side yet. We're still trying to figure out our rules. Okay, so what I need to do is to create a decimal times a base of 10 to an exponent. And I got to figure in what those two blanks are. So what decimal would I get from 3,725,000? Remembering what my rules say about scientific notation is the decimal has to be between 1 and 10. What would I be putting in the blank? Oh, certainly more than one person must have an idea. Breck? Say again real loud. So we have 3.725. Now, is our number considered a large number or small number? Large. So what kind of sign would I get?
Positive.
Okay, so I'm going to get a positive here. Now, do I need to put the positive in? No, but for our notes, we're going to put that in just so that we see a connection. So large numbers, positive. So I'm going to write that. Large, positive. Okay, now, what I need to figure out is how many places I moved that exponent. Or not the exponent, the decimal point. So what I like to do is just move 1, 2, 3, 4, 5, bam. And I just count up how many little loops I had, and I had a total of 6 loops. So my answer for 3,725,000 is 3.75 times 10 to the positive 6th power. Okay. Yes?
Wait, so how would you know where the decimal goes?
Remember, the value has to be between 1 and 10, so I move it until I have one digit in front of the decimal point. That's how I can guarantee it's between 1 and 10. Okay? So let's write out in words what we just did. So we move the decimal point so a decimal between 1 and 10 is created. The large number means a positive exponent. And the decimal moved 6 places to its new spot. Okay, so we move the decimal. So a decimal between 1 and 10 is created, so that's where the 3.725 comes from. The large number means we're going to get a positive exponent, and the decimal moved 6 places to its new spot, so that makes up our exponent value. All right, let's try one going the other direction. So I've got 0.00316. Let's see, tens, hundreds, thousands, 10,000s, 100,000s, millions. 316 millionths is how you would read that number with place value. Now, would we consider that number to be a large number, small number? And so what kind of exponent are we expecting? We're going to get a negative. So again, our frame is we need to find some sort of decimal value that's between 1 and 10. We're going to multiply it by a power of 10. And we already know that the exponent is going to be negative. Okay? So what decimal would we rewrite this number as that would fall between 1 and 10? So that's our parameters. Matt?
It would be 3.16 to the negative 4th power.
Okay, so let's just double check. We just move one spot at a time till we land where we need it to be. And we moved 1, 2, 3, 4 spots. So I agree the answer was 3.16 times 10 to the negative 4th power. So the only thing that changes, this is the same. I moved the decimal, so a decimal between 1 and 10 is created. This is what is going to be different. The small number, oops, means negative exponent. The second bit is pretty much the same, except for I moved 4 places to its new spot. Okay? So let's practice a couple of these. So now let's go over on the other page where we're going to do our practice. And our directions are going to be write each number in scientific notation. Write each number in scientific notation. 0.00876. We're going to get a decimal times 10 to some sort of exponent. Okay, so let's check it out. What kind of exponent should we get with this type of number? Okay, it's a small, so it should be a negative. Okay, what would the decimal value be, Zach? 8.76. To get that decimal in that new spot, how many places did I need to move it? 3. So my answer is 8.76 times 10 to the negative third power. That's it. Okay? Cameron, you need to wake up and you need to write down. Come on, bub. I don't know how you can sleep. It's too cold in here. How about 14,140,000? So again, I know I'm going to get some decimal between 1 and 10 times 10 to the some sort of power. Now what kind of sign am I going to get on mine? Yeah, it's a very large number, so we're going to get a positive here. Okay, and what would the decimal be that would be between 1 and 10? Kenzie, what do you think? 14? Say again, 14 point? Okay. Is 14 between 1 and 10? No. So we got to kind of amend that. So let's try a second time. What would it be, Kenzie? I let her go again. All right, there we go. Now that number is between 1 and 10. Okay, now my job is to figure out how far did I move it. So 1, 2, 3, 4, 5, 6, 7. So I moved it 7 places. So my answer is 1.414 times 10 to the positive 7th power. Now again, in your homework you don't need to write the plus sign. You only need to write a negative sign. Okay? All right. You guys feel pretty good, or you need another example? One more? Let's do one more. You want a hard one. Okay.
How many zeros is that?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 zeros and a 5. All right, what kind of exponent do I get on this one?
Negative.
Oh, yeah, super small number. All right, how would I write this number as a decimal between 1 and 10? What would that number be? Tyler? It would just be 5. Now, do I have to write 5.0?
No.
No. In math, we tend to, if the number is that, it's fine. But in science, they tend to want to have a digit after the decimal point, and they would write 5.0. So it's kind of a difference about what subject you're in. Now, the question is, how many places did I have to move it?
10.
That's it. So I heard 10. So let's see if you're right.
11.
Oh, I'm hearing arguing here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, 10 gives me 0.5. It actually does take one more to get around that 5. So the answer is 5 times 10 to the negative 11th. Okay? All right, great. Let's go back to the notes page. And let's talk about going the other direction. So now we want to go from scientific notation.
What if we're in space?
Then I guess maybe you'll have to write on the other side towards the bottom. Yeah. Yeah, I just was answering that question too. Yep. Scientific notation to standard form. So let's see. We'll have something like 5.34 times 10 to the 4th. What do you think I'm going to do to get this answer? Matt?
You're gonna have to go to some reverse operations.
Okay, what does that mean? Inverse.
Solve the problem backwards.
Okay, so how would I solve this problem backwards?
You can go 4 decimal points to the right.
Like this? Like that?
Yes, and then it'd be 53,400, and that's it.
Okay. I totally agree with that answer. Okay. So let's talk about what took place to get from that original problem to the answer. Where did the 4 places come from? Zach? That we had to move the decimal point. How did we know to move it 4 places? Okay. No, something in the original problem gave me clues what I was supposed to do. Okay. Let's see. Tyler? Yeah, the exponent told me. And not only did it tell me 4, but it also told me direction. Because what sign's on the 4? Positive. You think of a number line, what direction do you move that's considered the positive direction? To the right. Because the exponent is positive, we have what we know is going to be a large number. So positive exponent means we need a large number, which means we need to move the decimal right. Okay? That exponent gives me all the directions I need. It tells me what direction to move, and it tells me how many places to move. So the positive exponent is a large number. That large number says you're going to have to move the decimal right to show it as a large number, and the exponent also reveals how many places to move the decimal. So let's see if it works the reverse direction. Oops, let me change that color. So we have 3.27 times 10 to the negative 3rd. Now, who thinks they know what that answer would be written as a normal number? Juliana?
You move to the decimal to the left 3 times.
And that would give me what?
0.000327.
Like that?
Yeah.
Okay, so you said take the decimal point, move it left 3 times. Oh. I only see 2 blanks.
Oh, yeah. I meant, yeah.
Okay.
I wrote it wrong.
So we'll just correct it. Not a big deal. So basically, what I notice is that the negative exponent tells me I have a small number And to make a number smaller than what I see, I'm going to have to move the smaller direction, which means I'm going to have to move the decimal left. Exponent also reveals how many places to move the decimal. So this piece is exactly the same as the other piece. So these two pieces are the same. So the only big difference is here with a positive exponent, I move the decimal right. Here with a negative exponent, I move the decimal left. Okay? So that's not too hard. Let's do a couple of those. So we're going to go back to the example page. I think I have room on mine. Nope, I don't, because I need to put another set of directions. So the new directions would be write answer, or write each number, let's do it that way, in standard form. So let's see, we're number 4. So let's say we have 7.42 times 10 to the 5th. So what is that exponent telling us to do with the decimal? Okay, so we're going to move right because it's positive. And how many spots? 5. So 1, 2, 3, 4, 5. And then the only thing that we need to remember to do with our answer is fill in blanks. So we have the 7, we have the 4, we have the 2, and then we had 1, 2, 3 blanks. 1, 2, 3. Now, when it comes to standard form, if your number has 5 digits or more, you have to use a comma to separate them. Okay. So I'm going to add something we hadn't added before underneath here. Fill up blanks with what? Zeros. So any blank loopies, they get filled up with zeros. All right, let's do one more. So let's see, how about 6.1 times 10 to the negative 2nd? All right, so what does the exponent negative 2 tell me? We're going to move left. How many spots? 2 places. So 1, 2. And the answer would be point and 1 blank 0, 6, 1. Okay. Now the other thing that you may end up having to do in your homework is to compare numbers in scientific notation. Well, first thing that you can compare is look at their exponents. If their exponents are the same, then you look at the decimal. If their exponents aren't the same, the one that has the larger exponent is the larger number if they're positive. The one with the smaller exponent is actually larger if they're negative. That's the hard one, or the negatives. Okay, so they may ask you to do a little bit of comparing on your homework tonight.